Calc BC, Unit 3, Day 13, pretest for the test. A little mean value theorem in here. Find the C value guaranteed by mean value theorem. Now, the one mean value theorem that we discussed this unit specifically was the average derivative. And we said, okay, well, that's just the slope of the secant line connecting the two endpoints. It's good to show your setup. Look for near, it's going to be 64 minus 48 is 16 minus negative 2 over 4 minus 1. 18 over 3 is 6. So that's f prime average. So then f prime is 3x squared minus 6x equals 6. So move everything one side. 3x squared minus 6x minus 6 equals 0. Factor 3 out. X squared minus 2x minus 2. Not a very nice answer. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's going to be positive 2 plus or minus square root of 4 plus 8 is 12. Take square root of 4 out of that. There's a root 3 left. So we're going to get 1 plus root 3 and 1 minus root 3. Now it's got to be between the endpoints, so 1 plus root 3 is about 2.7, and 1 minus that's probably about negative 1, or about negative 0.7. Negative, yeah, so I don't know what. Okay, so we want the one that's between the endpoints. So this is your C value right here. This one will not be a C value because it's not between the endpoints. Okay, to a police officer stopped Carly after watching her drive 1 mile in 48 seconds. Is police officer justified in giving her a speeding ticket for breaking 74 mile an hour speed limit? Well, it kind of sounds like a good mean value theorem for derivatives issue. So the average speed would be how far she's gone, 1 mile from 0 miles in 48 seconds minus 0 seconds. But I think we want to get it into miles per hour. So this is miles per second. So we want to change these seconds to hours. So we're going to multiply by 1 hour over 60 minutes times 60 seconds. Right? So then that's going to be, the seconds go away. So we get 3,600 over 48 miles per hour. We can try and simplify this. 1,800, 24, 900 over 12, 450 over 6, 225 over 3, and 3 goes into that, 70, 225 divided by 3, 7, 75. So our average speed equals 75 miles per hour. She must have hit it at least once. Yes. All right. Okay, optimization. Mr. Twyford has $2,800 spent on a fence as shown. 3 sides connected to the kennel cost $10 a foot, while the side opposite the kennel costs $6 a foot. So connected to the kennel, $10 a foot. $10 a foot. So the solid ones. And then the one opposite, $6 a foot. If this is X, then this is X. And if this is 100, this is 80, then this is 20. And this is X minus 20. So we need to, we're trying to find a formula for the terms, in terms of X of the enclosed area. So area equals X times Y, right? We want to get in terms of one variable, so we have our cost, which equals 2,800, and that equals 10x plus 10x plus 6y plus 10 times parentheses x minus 20. So we could simplify this. 2,800 equals 30x plus 6y minus 200. And let's solve for y in terms of x. They specifically ask for in terms of x. Usually it's kind of up to you, but I think that'll be the cleaner one anyways. So 6y equals 3,000 minus 30x divided by 6. Y equals 635 times 500 minus 5x. So then we're going to plug that back in up here, and area equals x times 500 minus 5x. So there's our formula. We'll probably go ahead and distribute it. 500x minus 5x squared. Okay, and then find x and y when the enclosed area is maximized. So extreme value theorem, if possible. We got to figure out critical points. So a prime equals 500 minus 10x equals 0 undefined. So x equals 50 is our critical point. Endpoints, what's the smallest x to be? Not 0. If x is 0, you get negative fence here. Smallest x can be is 20 to avoid negative fences. What's the biggest x can be? Well, what's the smallest y can be? Y could be 0. So when y is 0, x is 100, right? So these are your endpoints. We make a table, x area. Now I like to use the factored version because it makes the work easier, and plus the 500 minus 5x, which will show up in your work, is your y value. And it's a little less work later on. 20, 50, 100. So you plug 20 in, it's 20 times 400 is 8,000. 50 times 5 times 50 is 250, 250. 5 times 25 is 125, add 2 zeros. 100 be 100 times 0, which is 0. So here's your min, here's your max. So now I think we're ready to answer our question. So the maximum enclosed area is 12,500 square feet when x equals 50 feet and y equals 250 feet by extreme value theorem. Checking endpoints and critical points. So I do expect justification, units, good answers, if you want full credit on your test. All right, kind of a classic optimization problem. Andy is on the bank of a river that's 6 miles wide. He wants to travel to point B from point A. He wants to walk 5 miles an hour. He wants to walk 5 miles per hour. So where he's walking. And then at some point he can row 4 miles per hour. Find the value of x, minimizing the entire time of the trip of the entire. So this is a good place to put x if they didn't already put it, because then this is nicely 10 minus x, and this is the square root of 36 plus x squared. And distance, d equals rt, distance equals rate times time, so time equals distance over rate. So time is going to be time walking plus time rowing. And time walking is going to be distance walking, which is 10 minus x divided by the rate of walking, which is 5. And time rowing is the square root of 36 plus x squared divided by 4. So there's our formula in terms of one variable, the thing that we're trying to maximize. So we need to find critical points, t prime equals, that's 2, which goes away, minus 1/5, plus this is like 1/2, right? So it's going to be 1/2 36 plus x squared. It's the negative 1/2 over 4 times 2x. You got a chain rule there. Don't forget that. And we're going to set it equal to 0 and define. I think the best strategy is to combine these into a single fraction, which isn't too hard. These common denominators can be negative 4 plus 5x. Well, actually, shoot. Let's rewrite this first. Negative 1/5 plus x over 4 square root 36 plus x squared. So least common denominator is going to have 20 square root of 36 plus x squared. So this is going to be negative 4 square root of 36 plus x squared plus 5x. All right, so undefined comes from the bottom. Show me what that is, just in case. So x squared equals negative 36, square root of both sides, plus or minus, x equals plus or minus I, 6i. I can do those. 0 comes from the top. So that's going to be 4 square root of 36 plus x squared equals 5x. Square both sides, get rid of the square root. 16 times 36 plus x squared equals 25x squared. So 16 times 36 is a big number. 36, carry 3 to 18 is 21. 0, 6, 3, 6, 7, 5, 576. 576 is going to stay over here. And then I'm going to subtract 16x squared over there. That's 9x squared. We're going to divide both sides by 9. 9 should go into 576. 9 goes into, let's see, 5 times 9 is 45. 6 times 9 is 54. 6. And then that'd be 4. So that's going to be 64, which works out nice. Square root of both sides, plus or minus. I need to see plus or minus, otherwise I'm taking off points. Okay. Now these are your critical points. We need endpoints, which x smallest x would be 0. We're not going to have a negative x. We're not going to go past it because it'll actually create time for us. And the biggest x would be 10. Those are the extreme cases of just rowing the whole way or walking as far as you can and rowing the shortest distance. But we also are going to get rid of this negative as far as calculations. So x, so we're going to do 0, 8, 10, and plug them into our time equation. Zero is going to give you 2 plus 6 over 4, which is 3 halves. So it's going to be 1/2, 3 1/2, or 7 halves. If you plug 10 in, you get 0. Square root of 136 over 4. I think we take 2 times 68, 2 times 34. So we could take a 2 out. So square root of 34 over 2, which is about, square root of 34 is close to square root of 36, so maybe like 5.9 over 2, which is like 2.5, 2.95. Okay. And 8, if we plug 8 in, we get 2/5. Square root of 100 is 10 over 4. Least common denominator would be 10. So that would be 4 plus 25 is 29 halves. 29 tenths. So that would be 2.9 exactly, which is really close to this. I mean, this was a rough answer. So this is where I might go ahead and allow you to use calculator. Square root of 34 divided by 2 is 2 is even closer than I thought, 2.915. Okay, so this is our min barely. This is our max. So we're going to say the answer is find the value of x, minimizing the trip. The minimum time for the trip is 2.9 hours when x equals 8 miles. I need units by extreme value theorem. Checking endpoints and critical points. So there you go. All right, moving on. Part C says locate x coordinates of relative minimum. Okay, let's do first derivative test most likely. So we need to take the derivative, which is going to be 4x to the 1/3 minus 8x to the negative 5/3. And you can show more work for that if you want. And we're going to set equal to 0 undefined, find critical points. I think factoring is probably the best. 4x to the negative 5/3, factor out the smallest exponent, which is the most negative exponent, if there are negative exponents, and then you're dividing it out. So this is going to be actually x to the 6/3 because you're subtracting negative 5/3 from positive 1/3, so it's 1/3 plus 5/3 is 6/3 minus 2. And so that is x squared. So you're going to get x squared equals 2, x equals plus or minus the square root of 2, and x equals 0. Now be careful if these have an even numerator, then that's going to be a root that bounces off the graph. But these are our critical points. And so then we're going to do a line check, label your line check. The critical points on there, test a value. I don't know, x equals 4. What's the derivative going to be? Well, that's going to be 16, that's going to be positive, that's going to be positive, that's going to be positive, negative, positive, negative. Now, the other thing to watch out for is the original function. Make sure that the domain is all good. If you have any even numbers in the denominators, then those are even roots, and you can't take those as negatives or division by 0. In fact, right here, this original function, now if we write it like this, that gives you x cannot be 0. So this is not in the domain. So the domain of our answer is negative infinity to 0 union 0 to positive infinity. So we can't give any answers where the domain doesn't exist. This graph doesn't exist. So it looks like decreasing, increasing, decreasing, increasing, relative min. This looks like a relative max. This looks like a relative min. But this one doesn't exist. The graph doesn't even exist there, so we can't give that one. So Now, you may have just accidentally got it right because we weren't asking for relative maxes and mins, but I probably would be looking for some kind of evidence to know that you didn't use that. So, anyways, relative minimums at x equals negative root 2 and positive root 2. Okay, got some business problems here, I guess. In marketing AGHS keychains, the school discovered that demand, which is the price based off the price you could sell things for, the cost of producing X items is this is total cost. This is price per keychain, right? So we want to do maximum profit. So first of all, profit is revenue minus cost. And in this case, revenue is the price times the number of items. And this is just the total cost. So, but we should probably put it in parentheses, make sure we distribute that subtraction. So profit is going to equal 50 square root x when you multiply this by 50 over square root of x minus 500 minus 1/2 x. It's your profit function, so we need to take the derivative of it like we normally would when we're trying to maximize something, find critical points. We get 25 over the square root of x minus 1/2. We're going to set it equal to 0 undefined to try and find this critical point. So we could give this the least common denominator, 50 minus square root of x over 2 square root of x equals 0 undefined. So one critical point is x equals 0, but we're gonna, I don't think that's gonna be an answer. Just making nothing, unless you just always lose money, no matter what, which I guess is possible. Zeros for this guy, so x equals square root of x equals 50. You got to square both sides, so x equals 2500. That's your critical point. Our endpoints, we can't make negative items, but there is no upper endpoint. So this is one of those ones where we can't really necessarily use extreme value theorem. So we're going to go ahead and settle for first derivative test, but I'm going to ask you to justify it on your test. So we'd say, all right, well, let's do p prime. And we got 0, we got 2500, test, x equals 1, that'd be easy. That'd be 49 or 2, that'd be positive, negative, negative, decreasing, increasing, decreasing. Now, if there were no endpoints, we wouldn't be able to tell. We'd be able to say that this is relative min and this is relative max, but we're considering producing 0 items, so we're not even looking at that. So this is for sure the highest point of this graph if we get rid of that, otherwise because it kept going up there. So, and then the actual profit still has to be calculated at 2,500 items. So that would be 50 times the square root of 2,500 minus 500 minus 1250. This is going to be 50 times 50. So that's going to be 2,500 minus 1,750 is going to give you 750 for your profit. Probably dollars, I guess. I don't know. Didn't say dollars necessarily, but so we're going to say the maximum profit is $750 when producing 2,500 keychains. Since x equals 2,500 is the location of a relative maximum. Oh, we're looking for, I don't know why I said in there. That's max, this is min. Relative maximum by the first derivative test. So you have to explain how first derivative test works. Since p prime of t was positive on the interval 0 to 2500, and p prime was negative on the interval 2500 to positive infinity, then we got to say, why is that relative maximum going to be an absolute maximum? Since it is the only critical point, relative extrema, it has to be, let's say, the only relative extrema has to be the absolute maximum, something like that. This is why we don't use first derivative test, if at all possible, when especially if you have to justify. One, it doesn't work most of the time. Two, if it does work, justifying it is a lot of work. Okay. Number 7, find the production level that minimizes the average cost per unit. So this is your cost. So average cost equals total cost over the number of units. So it's going to be 800 plus 0.04x plus 0.002x squared, and we're going to divide by x. So it's going to be 800 over x plus 0.04 plus 0.002x. So then we're going to take the derivative of that, and it's going to be negative 800 over x squared plus 0.002. We're going to set it equal to 0 undefined. So we're going to try and solve this. Negative 800 plus 0.002x squared all over x squared. So x equals 0 is a critical point, and this up here is going to be 800 equals 0.002x squared. We're going to divide by 0.002. Now this is, we could move the decimal point over 3 spots, and then we'd have to move it over 3 spots here. So that'd be 800,000 divided by 2, so that's 400,000. And then we would take the square root of both sides, plus or minus. So I think that's going to be, it's going to be 20 if it's just 400, and then another 2 zeros for 1,000. So those are your guys' critical points. Or I don't know. I think maybe I messed up. Let's see. We could take 4 times 100,000, right? That'd be 10 times 10,000. That'd be 10 times 1,000. That'd be 10 times 100. 10 times 10. So per 10s, 4. So x is going to equal 200 square root 10 plus or minus. Okay. So I'm going to make I don't have an endpoint, so I guess I'm going to try and do first derivative test. So AC prime, line check, label it. Test a value. Tell me what you test. 1. If I plugged 1 in here, that'd be negative. Positive be negative. Negative, positive, negative, positive. Now, we do have some restrictions. Like, we got to just throw all this out, right? And so this is a relative min. Before, if we didn't throw this out, we wouldn't be able to tell where the absolute maximum min was, because it could be the endpoints, could be critical point, but now this is clearly the only relative min. So we're going to say, I mean, we could calculate the average cost. It didn't really ask us to. We say the minimum average cost is at x equals 200 root 10 units since x equals 200 root 10 is a relative minimum. By the first derivative test. Since AC prime is negative on 0 to 200 root 10, and AC prime is positive on 200 root 10 to positive infinity, and is an absolute minimum since it is the only relative extrema. Something like that. All right. You don't want to use first derivative test as much as possible. Hopefully I've convinced you of that, because if you do, man, getting full credit is going to be hard. But sometimes we have to. All right. So that was all mostly review. I mean, the business stuff was new, but just application of old idea. All right, now for parametrics. So we've been doing a lot of these. Hopefully you feel comfortable with these. Sketch without a calculator. I want initial terminal points. I want direction. I want Cartesian equations. I want all that stuff. I mean, that's what I've been asking you all the time, right? So should be no questions about what I'm looking for here. Now, I usually use these trig identities, Pythagorean identities, for the ones that involve trig. So that, divide everything by sine squared. You can divide everything by cosine squared. We'll pick the one that works. So we're going to use the sine squared plus cosine squared for the first one. So sine is going to be x over 2 squared. Cosine is going to be y over negative 3 squared equals 1. So x squared over 4 plus y squared over 9 equals 1. So this is the Cartesian equation. This is an ellipse. Okay, I want you to identify the shape. We're going to sketch it. We're going to make a table, which will help you get your graph better too. I'm going to go and sketch the graph. Label the axes with values in x and y. Okay, I kind of like to draw a box on these, and then I'm going to draw the graph lightly first. Okay, now we're going to plug in 0 and 3 pi over 2. So sine of 0 is 0, so it's going to be 0. Cosine of 0 is 1, so it's going to be negative 3. So that 0, negative 3 right here, 0, negative 3 is the initial point. Okay? 3 pi over 2, sine of 3 pi over 2 is 1, so it's going to be 2. Cosine of 3 pi over 2 is 0, so it's going to be 0. So 2, 0 right here is the terminal point. Now, be careful, because some of you might just say, oh, well, then it must be this chunk of the graph. It must be going this direction. Well, let's calculate something in between. Pi is easy. That's going to be 0, positive 3. Oh, shoot. It's up there. This graph actually starts here and ends where we thought it does, but it takes the long way. Okay? And so the direction is like this, and the direction's on the graph. So there you go. Probably ask you to, maybe just write down the initial and terminal points nicely somewhere. Also in your graph, direction, name the shape, sketch a shape. So there we go. All right. I mean, these ones should seem kind of easy compared to those last problems with that first derivative test stuff. Okay, next we're going to use the one with, so tangent is y minus 3 squared plus 1 equals secant is 2 minus x squared. Now, I want the 1 to be positive, and so I'm going to move this over here. I'm going to rewrite 2 minus x squared is x minus 2 squared, because if you factor negative out square, it's going to be positive. It's going to go away. It's going to look just like this. Minus y minus 3 squared equals 1. This is a hyperbola because the x squared and y squared terms have different signs. It's also been shifted right 2 and up 3. Okay, so let's we're going to make a table. I'm going to draw a sketch of the graph. 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Okay, so 2, 3 is the center of it. And then you're going to go left 1, right 1, down 1, up 1. And draw a little box. And then you're going to connect diagonals by dashed line. Those are going to be slant asymptotes by the time we're done. And it's going to open left, right, not up, down, because the x squareds are positive. So there's the whole shape. So let's plug pi over 2 in, and pi, see what happens. So secant's 1 over cosine. Cosine of pi over 2 is 0. So we get negative infinity. Tangent sine of cosine. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. You also get positive infinity. Undefined. I think the infinities kind of help you understand what's happening. That probably means we're on one of those slant asymptotes that just blow up towards infinity. Pi is going to be 1 over cosine of pi is negative 1, so that's going to be 3. Sine of pi is 0 over cosine of pi is negative 1, 0. It's going to be 3, so 3, 3, which hopefully is on this graph. So here's 3, 3, 3, 3 right here. 3, 3 is your terminal point. There is no initial point. But we got to figure out what portion of the graph is. We still got to figure out what portion of the graph we have and the direction. So I put something else in between. I don't know, 3 pi over 4 is between pi over 2 and pi. 1 over cosine, that'd be root 2 over 2. 1 over root 2. And it would be negative because it's in the second quadrant, so it's going to be 2 plus root 2. And then sine over cosine, that's going to be 1, but it's in quadrant 2, so it's negative 1, so that's going to be 2. This is approximately, this is like 1.4, so it's like 3.4. It should look about right. 3.4, comma 2 is like right about there, so that kind of makes sense. So it looks like we're going this way, and we put an arrow on here showing that it keeps going, but we're coming in that way. So initial point, none, terminal point, 3, 3. There you go. That was kind of a weird one. Find some extra points. Okay. Okay, get another one. Find the values from 0 to 2 pi where the parametric curve is horizontal. So that's going to be when dy dx equals 0, the tangent is 0, but more specifically dy dt equals 0. There's no movement up or down, so it's flat. And hopefully dx dt doesn't equal 0 at the same time. We'll see if that comes out because we're going to be investigating that anyways because we're going to find dy dx equals undefined. It's blowing up to infinity. Division by 0 is going to happen when the denominator dx dt equals 0. So we'll figure out if it's happening both places. If it is, that's trouble. Doesn't mean it's not an answer. We just got to figure it out. So dy dt equals 1 plus 2 sine 2t. Got a little chain rule there. I say equals 0. So sine 2t equals negative 1/2. Alpha equals 1 to sine equal 1/2. Pi over 6 quadrants 3 and 4, it's negative. So we're going to get 2t equals quadrant 3 is going to be pi plus pi over 6, so 7 pi over 6 plus 2 pi k. And then 2t equals quadrant 4 is going to be 2 pi minus pi over 6, it's going to be 11 pi over 6 plus 2 pi k. And we're going to divide by 2, divide by 2, divide by 2. So t equals 7 pi over 12 plus pi k. And t equals 11 pi over 12 plus pi k. And we want all the answers between 0 and 2 pi. So that's going to be 7 pi over 12. But then another 12 pi over 12 would be 19 pi over 12. And then 11 pi over 12, and then 23 pi over 12. Those are all between 0 and 2 pi. So as long as none of these create dx dt equals 0 at the same time, then we feel good about these answers. If dx dt equals 0 at the same point, then we got to do like L'Hopital's rule and stuff. Over here, dx dt equals cosine t, and we're going to set it equals 0, and that's going to happen at pi over 2 plus pi k. So that's going to be at pi over 2 and 3 pi over 2. And since none of these values overlap, should be good. So there you go. Two-dimensional motion, just a little more. But maybe thinking of it more in terms of motion, speed, velocity, acceleration, all that kind of stuff. So we want the velocity vector. So the velocity vector is going to be, velocity at 2 is going to be x component and y component. So Vx is going to be x prime t, which is 2t plus 1. And so then Vx at time 2 is going to be 5. And then Vy is going to be y prime, which is going to be 2t minus 1. So Vy at 2 is going to be 3. So that's your velocity vector. Okay, speed. Speed is the absolute value of velocity, but in this case, these problems that we're doing now, velocity is like that. That's a velocity. And we break it down into our x and y components. So we can use Pythagorean theorem to find the length of the hypotenuse, which would be the length of this, this magnitude of it. So it's going to be square root of Vx, and we want it at time 2. So we want that. And I think we just found this, so that's going to be helpful. Right? We just found those, so we can use those values. Square root of 5 squared plus 3 squared. 25 plus 9 is the square root of 34 is the speed. No units on this problem. Okay. T value for which y of t is relative min. So that's going to be extreme value theorem. So, no, relative min. Oh, okay, that's kind of interesting. Relative min. All right. So we're going to want to find y prime to find critical points, which is vy, which we found was 2t minus 1. We're going to set it equals 0 and define. And so t equals 1/2 is your critical point. And so we can just do a line check. Test a point. T equals 1, positive, negative. It's moving down, moving up. Relative min right there. So, all right. The t value for which yt has relative min is going to be at t equals 1/2. X coordinate when Albert flies horizontally. So it's kind of like that question above when we talked about horizontal movement. That's going to be when dy dx equals 0, flat tangent line. Specifically, that's going to be when dy dt equals 0. And dy dt, which we already found, y prime is 2t minus 1. So t equals positive 1/2. Now that's the time when that happens. But we want the x coordinate. So we're going to plug that into our x equation from the beginning. And we're going to get 3/4. So there you go, 3/4. Okay, now for a little gravity problem, two-dimensional problem with gravity. Trevor kicks cow patty from ground level. So that's going to be y equals 0. Why not? This is your initial velocity. It's at this angle. So we got to find all our equations. I would draw a picture. Okay. 128 feet per second. So your initial velocity. You're going to break it down to Vx sub 0, Vy sub 0. It's at a 30-degree angle with the ground, so that makes it easier. We don't have to use weird trig and get ugly values. Now this is going to keep going like this, right? And eventually hit the ground. Right now, this is the hypotenuse, this is a short leg, so it's going to be 64. This is a long leg, 64 root 3. So we need those. And so for y, it's going to be negative 16t squared plus 64t plus the initial height is 0. Velocity is going to be negative 32t plus 64. Acceleration is going to be negative 32. For x, you don't get the gravity part. So it's just initial velocity times t. And then the velocity is 64 root 3 all the time, and acceleration is 0 all the time. So there's your equations. Now, max height cow patty is also going to require time of impact. So let's find the time of impact first. And so time of impact is going to be when y equals 0. So negative 16t squared plus 64t. And so we could factor a negative 16t out. And we get t equals 0 and t equals 4. T equals 0 makes sense because that's where it starts, ground level, but it's 4 that we're looking for. So seconds, units are important here. So max height is max y. Our endpoints are 0 to 4. Time of impact we just found. We need to find y prime. which is the same as Vy, which is -32t plus 64, and set it equal to 0. And we get t equals 2 for a critical point, turning point. So we're going to make a table, plug time in to y, plug 0 in, 2 in, and 4. Now 0 gives us 0, no surprise, initial height is 0. 4 gives us 0, no surprise because that's how we found 4. And 2 gives you -64 plus 64, no, sorry, gives you -64 plus 128 is 64. So there's your max. These are your mins. So I need justification. Then we're going to write the answer nice. I'm going to say the maximum height is 64 feet at time t equals 2 seconds by extreme value theorem. Checking endpoints, critical points. There you go. All right. Horizontal displacement. That's just how far it went along the ground. And so that's just horizontal displacement. So it's going to be x at impact minus initial x, which is 0 on here. So it's just going to be x4. x4 equals 64 root 3 times t, which is 4. So it's going to be 128, 256 root 3. The units are feet. Okay. Arc length, that's the actual length of the path. And that's where we do the integral of speed, just like we did last year with one-dimensional motion. But this year it's going to have to be the square root of dx dt squared plus dy dt squared dt. So we're going to start at 0 and end at 4. Square root. Dx dt was 64 root 3 all the time. Dy dt was -32 t plus 64 squared dt. At least show the setup. I'm probably gonna let you use a calculator to just find this answer, but I want the setup. Unless it's easy to find, but this one, I mean, you're not gonna be able to find it on this one. You try, but it's a losing battle. So on your calculator, Math 9, square root of 64 root 3 close squared plus parentheses -32 plus -32x plus 64 close squared close comma x comma 0 comma 4 466.933 feet are the units, or 466.934 if you want to round. So there you go, bunch of good stuff there. And last, nice free response style problem, which really is just like all the problems we've been doing, but just a bunch of it all together. So let's see if we can do this one before my video runs out. I don't know, my videos like to get cut off around an hour, so we'll see. Okay, we can use a graphing calculator. So probably one of the first things I'm gonna do is enter these in to my y equals mini, square root, x to the 4th plus 9, and 2e to the x close plus 5e to the negative x close. I don't know what the window is yet. I'm just putting those in to make it convenient to vars, y vars. times 0. This is x0 equals 4, y0 equals 1. They gave you the derivatives, the velocities. Find the speed of the particle and its acceleration vector. So speed, we just talked about this, is the square root of dx dt squared plus dy dt squared. So that's going to be at time 0. If you plug 0 in here, you get square root of 9 squared plus 2e to the 0 would be 2 plus 5e to the 0 would be 5 squared. So this is going to be the square root of 49 plus 9 is 58. So that's your, no units on this. So that's your speed. Okay. At time t equals 0. Acceleration vector, well, we got to find the separate acceleration. So acceleration in the x direction at time 0 is going to be equal to the derivative of the velocity in the x direction at time 0. And acceleration in the y direction at time 0 is going to be equal to the derivative of velocity in the y direction at time 0. I'm going to let my calculator do these. I already put them in on the y menu, so I'm going to do math 8, bars, y bars function, y1, comma x, comma 0. That's my first one. Do it again. Bars, y bars function, y2. Okay, there we go. So 0, negative 3.0000005. So our final answer, acceleration times 0 as a vector is 0.000, negative 3.000. If you want to emphasize your 3 decimal accuracy, okay, there we go. Part B says, find the equation of the tangent line to the path of the particle. Okay, at time 0. Well, let's see. We have the point. So all we need is the slope, which is going to be dy dx, which is dy dt over dx dt, which we already have been given 2e to the t plus 5e to the negative t over the square root of t to the 4th plus 9. So we're going to plug 0 into that, and we're going to get 2 plus 5 over the square root of 0 plus 9 is 7 over the square root of 9 is 3 is 7/3. So y minus 1 equals 7/3, x minus 4. Leave it, done. Leave it in point slope form. It's quicker, less mistakes. Okay, C says find the total distance traveled by the particle total distance. So that's integral of speed, right? Just the integral of the square root of dx dt squared plus dy dt squared dt. I need all the setup right here. So we're going to go, and this is good enough for setup, but it says between 0 and 3, so 0 to 3. So I need this. You do that. You could write them in here, but that's just not necessary. But if you wanted to, you could. Square root of t to the 4th plus 9 squared, 2e to the t plus 5e to the negative t squared. And you could write this, but you don't have to. This is fine because this is the way they named them. So, and that's why I haven't stored my calculator anyways. So we're going to do math 9, square root, bars, y bars function, y1 squared, plus bars, y bars function, y2 squared, close the square root, comma x, comma 0, comma 3, and we get 45.226818. So 45.226 or 45.227 if you want to round. No units on this problem. Okay. And then D says, find the x coordinate of the position of the particle at time 3. So this is where we're going to use fundamental theorem of calculus, part 1. It's a very common thing that we use in a lot of different kinds of problems in Calc AB. And that says, okay, well, we have x prime, and if we integrate x prime, we get x, right? Integrals undo derivatives. The problem is that you can't integrate that. You can't integrate it by hand. And even if you could, don't, because you have a graphing calculator. So we're going to use the time we know, time 0, and use it to help us find time 3. So it's going to be x3 minus x0. So this is fundamental theorem of calculus part 1, right? If you integrate and integrate a derivative, you get the original function, plug limits in, top first, bottom second. So this is what we're trying to find. We know x0 is 4. So I'm going to rewrite this. x3 equals 4 plus the integral 0 to 3 of the square root of t to the 4th plus 9 dt. I mean, you could write dx dt there if you want, but this is for sure. This is really good setup, and you're going to need to show the setup to get full credit. So then I'm going to do 4 plus math 9, vars y, vars function y1, comma x, comma 0, comma 3. And there it is, 17.930790. So x3 equals 17.930 or 17.931 if you want to round. If they asked you for the coordinates of the point, you'd have to do it again to find the y value, but you just do the same thing. And the y one, I think you could actually integrate by hand, but don't, like if you have a graphing calculator, let the graphing calculator do it for you. So 1 hour. That was a long, good prep for your test, pretest. You ready?